If it wets the cone completely means theta will be 0. Himself he has given angle of contact. So therefore we have to show it. So how the liquid will take shape here? The liquid here will be like this. No, what is that theta? That theta is what? This one. How the force due to sufficient should act? Should act like this. Fs dash, or just write F dash. Huh? It is understood. The weight of the solid and the buoyant force. Then let's get into first. We'll calculate the force due to surface tension. Anybody how to calculate? For that we know what is the distance at this particular point, especially. We should know this x, no? X, and this is y. Sorry, this is h by 4. 3h by 4, let it be immersed. So we know already h by 4. So can we calculate x? So this will be tan alpha equal to x by tan alpha. Then force due to surface tension, how much it should be? Radius will become x, no? So therefore 2 pi x surface tension into 2 pi x into cos theta. Please do notice here why it will happen. So here you draw a ring. The force everywhere will be acting like this. And this is the vertical theta. Now you have to ask questions. Why you are taking? Because how the force due to surface should act tangential, no? Because this is a free surface. Come to the angle of contact. This is a solid surface. And this is a liquid surface. So what is the angle of contact? The angle measured between the tangent drawn between it's like what is the angle of contact? The angle measured inside the liquid between the tangent drawn on the free surface and the solid surface. You should measure inside. No, not this is not angle of contact. If the water wets the cone completely, tell me how this F dash will act along the slant length. Okay, no. Anybody wants to question this? Is it only this much? Because how do this net force due to surface should act? Should act vertically. Yeah? Then what is the angle made by this force? Not just theta, it should be theta plus alpha. Will I agree?
Yes, sir.
Very, very good minute observation is needed. Huh? If the water wets the cone completely, then what happens? It will become F cos alpha. Theta will be 0. So therefore, this should be theta plus alpha. E is what? Not only say many will make mistake here. Okay, let's get into buoyant force. So what is the buoyant force? Density of water. Volume immersed. How to calculate volume immersed? In the volume of beaker cone, 1 by 3 pi r square h into g. In the bigger volume, I should subtract the smaller volume. So this should be 1 by 3 pi x square. What is the height of this cone? H by 4 into g. Volume immersed. Okay, there's a volume immersed. No, this part is volume immersed. In the bigger cone, I'll subtract the volume of this smaller cone. I think some small geometry, nothing big, no. So just a student must have what like the geometry clarity is needed. Okay, now we got the buoyant force, so we know weight of the solid. But we don't know radius, no? So from where we are bringing radius? What is radius? This what radius we have assumed it. So actually, what is again tan alpha or again you should replace this one with a tan alpha. No, but we don't know x equal to h by 4 tan alpha. Fine. So that you replace, you'll get by and 4. So then what about the weight of solid? Weight of solid should be density pi r square h by 3. Okay, there's no problem with this. So again, we should replace r. Solve all this, you'll get expression for surface tension. We have to fight with the conditions. Nothing is there. So there's everything here is what is present. So now shall I suggest you? Different shaped objects. There'll be some immersed, some there'll be floating. Huh? So you have to be very careful. Sometimes we take the vector. Means what is the thing? When we should take the effective length, when we should not take. When we should take effective length, when we should not take. If different points, look, if every point on the structure, if the force acts in the same direction, so here force is acting different, but you see the horizontal component will cancel, vertical components will get added up. At different points on the structure, if the direction of force is different, you should go for integration. But here what happened, the magnitude is same and only the direction you can see. So here what happened, you should just take the component of force, all will get added up in one direction. So therefore directly for surface tension into the perimeter length. I think this will be a little bit challenging. So when to take that effective length, when not to take is what you should have that particular observation. Fine. So it will be very challenging. Everywhere the questions are coming with a very different approach. So definitely I'll suggest students like get familiar with all different shape of structure. Even this year is asked a little bit some different question it was there even this year, previous year also. Every year the advanced papers they're coming with a very challenging diagrams. Today only you might have seen, no, the different types of conditions you have come. Okay, pyramid is there, cone is there, cube is there, hemispheral immerse, like a hemisphere in different orientation immerse.